Hey everybody, hello there. So these are the types of chemical reactions. These should be fairly familiar to you because your job last night was to write the definitions for all of these. So part C, types of chemical reactions. And the first one is synthesis. And I'll have you, why don't you go ahead and hit the enter button, let's wait till it focuses, there we go. And I've got some symbols to represent what's happening, so if they need a moment to write that, please do. Then we'll hit the enter again to get it started. So at the synthesis reaction, the word synthesis means, building something from smaller stuff. So we're just using R and S to represent the compounds. So you've got two different compounds coming together to make a molecule. This could be like, two elements making now a molecule. That's synthesis. The next one is decomposition. So go ahead and give yourself a moment. Let's everybody get those copied down. So on this one with decomposition means breakdown. When out in nature, when things are decomposing, they're breaking down. So if we've got a molecule here, and if it goes through a decomposition, it is separating into the elements that made it up. So that's decomposition. And let's go on to number 3 here. Okay, number 3 is a single replacement reaction. So with this one, okay, go ahead and write it down. Go ahead and hit enter, and then I'll explain it here in a moment. So with this one, this is my analogy for replacement reactions are you've got a pair of people out on the dance floor dancing, and there's one person standing over here on the side, and they decide after a while, hey, I'm going to come over here and cut into the dance. So we've got this element T plus we have the compound RS. Well, it's going to break down, and what's going to happen is T is going to come over here, take the place of R. Now, R is off by itself. And then you got another pair of dancers there. So that's my analogy for replacement reactions. Think about somebody out on the dance floor. Which brings us to the next type, double replacement. And I guess I better zoom that out. Now this tends to just take place with ionic compounds, but go ahead, I'll pause while you go ahead and let students get a chance to draw that and write that out. So now a double replacement reaction. So kind of imagine we got two pairs of dancers out there. You're dancing away, and then you decide, hey, let's trade partners. It'd be kind of fun. Maybe it's a square dance or something. So RS now teams up with this partner right there, and then these two trade partners, and we end up with this over there. So that can happen, and we'll be doing a lab next week where we'll be mixing those together. And when that happens, we usually get what they call a precipitate. One of these tends to fall out of solution. It's kind of fun to see. So anyway, so there's the first 3. And then the last one is going to be a combustion reaction. And let's go ahead and get this written in. And then I'll go over that, so give everybody a chance to get that going. Now with the combustion reaction, don't get tweaked out about the X and the Y. That's just, it's some hydrocarbon compound, right? And what it is, which is basically, this is a fuel. It's going to oxidize, it's going to react with oxygen, and it's going to form CO2 and water. So this is what happens when we burn fuels. Well, most fuels, this is, of course, a lot of times we get smoke and soot and such. So now on table 22.1 on page 695, there's this table right here, and some of those names you're probably familiar with. You may have heard of methane. If not, you're familiar with it. It's the gas that mammals make when we eat too many beans. Ethane, you're probably not familiar with it. It's a 2-carbon compound. Propane, you've heard of, and it's just 3 carbons and 8 hydrogens. Butane, okay, look at right here, butane lighters, okay? Cool, so you're pretty familiar with butane. And then there's some bigger ones and such. But the main thing is that with a combustion reaction, you are mixing one of these you're burning one of these hydrocarbons. and you're going to end up getting CO2 and water out of there. And so there you go. When we have these types of reactions, you will need to be able to identify, are you combining two smaller elements or compounds into a new compound? Are you breaking one apart? Are you replacing one element in a compound with another? That's this one. Or do you have two compounds and the reaction makes them switch partners completely? Or is it combustion? Are we burning something? Are we burning a fuel in the presence of oxygen to make CO2 gas and water? It's kind of cool. That's one of the things I really think is so cool about hydrogen fuel cell vehicles is that hydrogen fuel cell vehicles, it's so cool because look, if you have hydrogen gas right here, H2, and it's reacting with oxygen, okay, it's going to form H2O on there. So this is a type of a combustion reaction where there's not a hydrocarbon, it's just hydrogen. Now let's see, this is not balanced. Let's see. Okay, I'm going to take a chance and do this. I need to, okay, so now hydrogen fuel cell vehicles, they oxidize, they burn hydrogen, but look at the waste product is steam, because this is usually plus heat comes out as well. That is so cool. Boy, when I get a chance, I'm going to buy a hydrogen fuel cell car because that'll be neat. Okay, so with that, we are done with these notes right here, and we'll get working on the next task here.